All right, well, welcome to the Node and Docker panel here today. I'm Joab Jackson. I'm from the News Stack. We're a news site covering these technologies. A few weeks ago, we were actually at DockerCon EU, and now that we're here, it's remarkable to see the similarities between the trajectories of Docker, containers in general, and Node. Both are fairly recent technologies that have been making quite an impression by radically simplifying the processes of developing and deploying software. Like what we know about Node, it allows you to, it spins up very quickly and allows you to get apps running with speed, and it cuts down on a lot of the overhead that you'd otherwise have to deal with in getting an application to run. Docker works, it kind of does a similar thing for deployment. The build that you're working on your laptop is the same one that runs in the data center, so you don't have to fiddle with all the bits in between as you're going through QA and testing. So you would think that there might be, if you put the two together, that there might be, you could even get greater efficiencies. And that's what we want to explore today on this particular panel. What we want to look at is the benefits that containers can the benefits that containers can bring to Node deployments, and the way Node could thrive in a container-based environment. Yeah, let's start off. Let's have the panelists introduce themselves. Start with Bryan.
Hi, I'm Bryan Cantrill. I'm the CTO of Joyent, corporate steward of Node for, I guess it would end up being 5 years, and now member of the Node Foundation.
Hi, Jacob Groundwater. I work in New Relic, and I work on a team. I actually originally worked on Node.js instrumentation there. I recently moved to a new team called Product Research. So my concern is more in the rapid iteration of trying things out. So I'll bring that to the panel, I guess.
I'm Matt Hernandez. I'm a product manager at Modulus, where we do Node.js deployments with Docker. So that's where I'm coming from.
I'm Peter Elger. I head up engineering for NearForm. We're a Node.js consultancy. So we work a lot with clients on software development projects, and also get a bit involved in some of the DevOps with them, and try and figure out how they can best adopt Docker and other technologies for deployment.
And I'm Alex Williams. I'm founder, editor-in-chief of the News Stack, and so I'm here with Joab to come out into the audience and ask questions during the discussion. So if you have some questions, let me know, and I'll be out there with my mic.
Alex, do I sound dated if I drop a Phil Donahue reference? Is that
you know, if people,
Phil Donahue is?
you know, I'm not sure if people are that old here, but yeah, sure. Yeah, I'll go out there. I'll keep my glasses on. I'll be like, hey, everybody. Yeah, sure.
There we go. All right, now we're both sounding old.
All right, so let's kick it off. Well, first, let me ask, what are the benefits of Docker and containers in general? What could they bring to a Node deployment?
Well, I'll go ahead and be the lead-off batter here. So I'm just going to continue on the theme of sounding too old, and I'm going to say that they are two great tastes that taste great together, which is peanut butter and chocolate. And if you don't get that reference, I'm sorry, you're just not cultured properly. Your parents didn't bring you up properly. That's what Reese's is. An ad from the 80s. No, Node and Docker are a great fit for one another. I mean, just for the reasons that you described, and containers more generally. Containers and Node are a great fit for one another. And they very much grew up together. I mean, I think it's kind of an interesting question of what is accelerating what. You know, I think you can plausibly argue that I think both of these things are accelerating the other. That the rise of Node is being accelerated by containers, is accelerating containers, and not just Node.
But I think bringing up the fact that differentiating between even just containers and Docker too is important.
Yes.
I think containers is really centering around the problem that we're all trying to solve, and Docker was the best solution so far for that. I mean, you're probably going to have something to say
no,
there. But
no, that's right. Did the vomit come out? Or
No, it just spilled on me slightly.
Yeah, I'm sorry. I didn't mean to.
But we tend to use it kind of like the Kleenex sometimes. Like, like, oh, it's Docker, and we were just referring to containers.
That's a very good point. Yeah, I think that Docker, when we say containers, when I say containers, I really mean OS-based virtualization. So virtualizing not at the hardware layer, which is the way we do it when we're running in AWS or VMware, what have you, but virtualizing at the operating system layer, where you've got many different apps that are sharing the same operating system kernel, but are in their own virtualized world. So Docker is what popularized it, really. But
and some people are using it for kind of lightweight virtualization, but containers in general, I think, also have the potential for like package management solutions or just like safe processes. Like maybe I want to like download some code that you put up on GitHub. I'm not going to review the whole thing. I don't 100% trust you, but I kind of mostly trust you. And there's some like
not me personally, but
you personally.
I know I'm.
But this is getting very kumbaya here already on Docker and containers, and I'm not very happy about it.
Should we stop holding hands? I mean, is that what you're upset about? What's going on?
Docker.
I think, they are a great fit together. Node and Docker are a superb fit. I think the other thing that's driving it as well is the adoption of microservice type architectures. The reason those
All right,
are
everyone
here's
drink
the poll.
microservices. Can you drink at the social?
Raise your hand.
Please, everyone
Who's
raise
doing
your glass.
microservices here? We have a pretty good crowd of microservices.
Okay.
Wasn't
And who is deploying microservices before we call it the microservices? Who is deploying microservices and didn't even realize they're micro? Exactly. Right.
Absolutely, yeah. Of course, it's a buzzword, right? But I think the real point under it is that underlying it is the need for people to want to go faster. And we see this with our clients all the time. We want to go fast. We want to go fast. We want to get features developed rapidly. Node allows you to do that. We want to get features into production rapidly. Docker helps you to do that. And I think that's the perfect storm that's forming around these technologies.
So speed.
Right.
That's what it's all about.
It is all about
speed.
Yeah. And I think this is what I think that Uber and Amazon have managed to shake up mainstream commerce in a way that other revolutions didn't. Absolutely. In that you go into arbitrary companies and people are terrified of their competition, and software's eating the world, and it is about using software as a competitive weapon and moving very quickly. And it's all about you're nodding your head. You saw you got some hippie sentiment over there. What's going on?
I'm sure what you speak is like this universal utopia, this truth. But what are the trade-offs, really? I mean, let's get down to the heart of it, because we could talk all day long about how well they work together. But I think it's important to first of all, quantify that with some use cases, and secondly, there have to be trade-offs. And I think the number one is complexity. You're going to have that's what comes with containers at some point.
Start talking about schedulers.
I mean, even anyone who hasn't gone through kind of the Docker CLI and kind of dealt with the bumps and the dents along the road, if you go to a meeting and they just want to get some code demoed, it can actually be an obstruction. So sometimes it's just simpler to avoid it until later. Generally everyone has their I learned the idiosyncrasies of the Docker CLI moment, and then usually after that they're better. But up until then,
or permanently enraged.
Whatever.
I mean, it's not quite a Git moment.
No, I mean, you're always kind of permanently enraged with the software that you love. Or you're not permanently enraged with Node somewhat.
Rage is actually a sign of love in high tech. It's actually.
I think so. I mean,
rage equals love.
It's screwed up. I'm not defending it. I'm just observing it.
I mean, we use Git, and there's so many enraging moments
minus pretty
Git.
equals 4. Can I just get that off my chest? I'm sorry. Minus 4 is not a word.
Matt, can you bring some sanity to this, please?
Sorry.
It's just out of control now. I'm just kind of trying to keep up.
Well, we're looking at you for the solution.
But now you have to give us the answer.
I got nothing.
No, okay.
But Matt, you were mentioning scheduling, which I think we kind of glossed over, but I think it's a very important point.
Yeah, I mean, that's what happens. So people start doing the Docker thing, and then they realize that they need to manage all of these instances and all this stuff, and then more buzzwords come out. You get Swarm, Kubernetes, also Drink, Kubernetes, and then now we have Elastic Container Services that are coming up. We got all kinds of stuff that making our lives easier, but we're just managing different things.
Right? Well, yeah, a question that I was asking people at KubeCon was, are we at or near peak confusion in the container space? and I think
you said we're not there yet.
I don't think we're there. I think actually some people are I think it's accelerating.
I think it is.
God save us all if it's accelerating.
I was I got here. I'm now you're going to talk about Node and the containers? Come on, stop
now.
Right.
One of these technologies needs to go home. That's what I feel like when HashiCorp announced Nomad. I'm like, you need to stop. I'm sorry. This is a great technology. It's very valuable. You need to turn it off. I'm sorry. It's just it's too much. We
Now
can't do
people
that.
are calling things containers, and they're not even containers, too.
It's a mess. Well, so how do you think it's going to resolve? I mean, I'd be curious to know what other folks think of that. Just how this.
I'm a reporter. I'm not going to.
Right. You're banking on the confusion. You want to feed it. Confusion is eyeballs.
I mean, the most technically perfect solution generally isn't the one that we go with in the end.
Hey! Come on, that's an insult to the technically perfect solution.
Are you intelligently designed? Are you telling me that?
Absolutely.
No, I mean, there's this line between technically perfect and kind of what the human needs on the other side, and like I think the container space is still trying to find that. Like, you can worry about, if you're not solving the human need, it doesn't yet matter if you're really like technically perfect, but like you really want to go for the human need first. This is my product research like spilling out, but I mean, solve something people want solved, and then you can kind of start going into like, are we solving it the most efficient way technically under the hood? And I think we're actually still navigating that territory. We're still
trying to solve the problems.
Yeah, I mean,
such
the
as...
lines between like, am I a developer and I learn about Docker, or I'm a DevOps, like that's still bleeding a bit. And I think that boundary is still, what do you call it? Like congealing? I don't know what to call that. Like coming.
Well, conversely, though, I mean, are there synergies to be had by pairing Node and Docker?
Yeah.
Oh, for sure.
Well, I heard that, I was talking with Dan Shaw, and he had said that, nodes, you got a single thread in the memory of a huge server. It's fending for itself. It's good to put it in a container so you can get the resources it's needed. I mean, along these lines, how will Node... In what ways is it an advantage to put Node in a container?
Well, I mean, Node, like containers, Node is lightweight. Containers are lightweight.
Yeah.
And the value of Node is that you can actually have a bunch of asynchronous activity going on without actually having a bunch of threads behind that activity. And that is the power of Node, that you don't actually need a 120 gig JVM to actually have a huge amount of asynchrony. And as a result, you can build these, drink again, microservices. I mean, Node plus containers, Docker, that is the ideal building blocks for microservices. They are that shrink to fit, and I thought it was great. In your presentation, you were mentioning that this is the Unix philosophy, right?
Absolutely.
And microservices are the Unix philosophy brought to distributed systems, and Node's an embodiment of those Unix abstractions. Containers are very much come out of that Unix tradition. Absolutely. And I mean, as a result, all three of these things are in that small systems Unix philosophy, and they're all very, I think, ideologically compatible with one another.
Oh, absolutely, yeah, absolutely they are. You're right, and that notion of doing one thing well and capturing that unit and being able to deploy it, and again with containers you're doing immutable deployments. You've got all of these other good things that in the previous world where you're mutating servers and things start to get really messy. There is a whole bunch of advantages to using containers and focusing on doing things well within that box, right?
Think also how Node packages its dependencies by actually having them as a subdirectory, like speaks to the way we're thinking about containers now. It's like, I just want to pack all the dependencies I'm going to need within this one bundle, which is your new build artifact. But Node, you're already kind of thinking that way. I've got my Node modules folder, everything's in there. Right. Can I just copy this directory in? And you're not really thinking in terms of like, maybe some other systems where it's putting modules in global part pieces and linking against system packages installed. Like, I've gotten into trouble with that. I'm sure everyone here has gotten into trouble with that. Go ahead.
Well, I would say that ironically, that is actually the actual genesis of containers back in the day. For us, so I was at
back in the day.
Back in the day. That's fine. So I was at Sun for 14 years prior to coming to Joyent, and we developed zones at Sun to sell you these big honking machines. And the reason that we needed containers back in the day is because these two apps, you could have even two versions of the same app that could not share the same physical hardware because they conflicted over what a flag meant in a configuration file or what have you. And containers were an easy way of giving them their own virtual world. I always thought that Node actually did it pretty elegantly in terms of even allowing conflicting code within the same program to coexist. But I think containers take that, to its kind of logical extreme, and it is the second coming of static linking. This is like the end of days. The days of reckoning are here.
You didn't say it, did you? What are the shortcomings? Come on. What are the shortcomings of these very lightweight systems working together?
Well, they're not that lightweight.
What?
I mean, Docker images can be quite large. And
true.
There's not a great deduplication story yet. You make one wrong move and suddenly you're copying another 500 megabytes, even though you change one file, for example. The kind of the caching mechanism is very coarse, I guess you could say.
I think to me the elephant in the room is that when you go to microservices, you're building a distributed system.
Yes.
And everyone's like, "Yay, distributed systems!" It's like, "Yay, no, yay, I'm going to Afghanistan." It's like, "No, it's a war zone. Pack your Kalashnikov. This is a beautiful country, but like you're gonna get shot up." And that is kind of it's a backpacking trip through the Hindu Kush. You got to actually know what you're doing. And I think that with distributed systems, there's a dark side, right? And when these systems misbehave, instead of having kind of clean misbehavior, you now have this emergent behavior. And instead of having a house fire, you now have influenza. And you'd rather have a house fire, frankly, than influenza.
Yeah, you can get through, yeah.
I think it was like 15 metaphors in one
Yeah.
sentence.
That's pretty good.
I'm going for the in-house record here.
That's why I walk off the stage.
That's right.
Just going back, there's some infrastructure in my organization that I need to deploy some code to. Having a well-defined target about what that is, and they go, "Oh, well, it's a Docker container." That's fucking fantastic.
Nice.
It's way faster than if it was the whole VM too, because I can package the Docker container on my machine, kind of ship it atomically to the system. I'm not like logging in and, "Hey, can you provision me a VM?" And like sometimes that's an API call, sometimes that's like a 6-month purchase order type of thing. So having that well-defined target is great. Having said that, the more and more you use this, you'll find that there are weird things. Like when if you have compiled modules and you're developing on a Mac, you need to run the compilation in the Linux VM basically, or in the Linux system. So that if you get your order wrong, you might end up calling it like an npm install every time you change one thing, just because of how the caching mechanism works. And then you're shipping all of that again over the wire. So people start kind of coming up with I know someone who checks in their package JSON file, then runs npm install, then checks in all their code. And that exploits the caching mechanism Docker to not rerun all the packaging. But it's just oh, that's kind of funny. And I think we should kind of keep track of these, because we may want to loop back and go, okay, can we fix these on the second coming or third coming of containers, when you'll be extra grandpa telling us all the old stories.
I cannot wait to be truly old. It's gonna be great. I'm gonna be such a pain in the ass to deal with.
Who out here says that they're building out microservices with Docker and Node? All right, great. Can I ask you a question quickly? Do you mind?
Did you ever use just
ask a
LXC
question
containers, just
relevant
Linux
to
containers prior
what
to
you're
the
doing right
Docker
now?
versioning
Or
thing?
tell us what you're doing.
Sorry.
We got a question here.
Sure. Yeah, we'll come back to your question. Yeah. This is what Alex does. He walks around with a dead mic.
There's all this trick in the book.
Exactly.
He wants me to ask a question relevant to what I'm doing right now.
Yeah.
So right now, my team is deploying containerized Node applications on Beanstalk.
On what?
On Beanstalk, Elastic Beanstalk in AWS. So this is less of a question and more of a probe to get you talking about this, but one of the biggest hurdles we face is dev ergonomics. Yeah, we can all rave about how awesome it is to ship off Node in a container because it's an artifact build and it's going to run the same out there as it does right here. But when you're a dev working on your local machine, and like you said, you have these binary Node add-ons, the gap between simply running the Node binary on my machine and then actually running it in the container and duplicating the environment that it's going to run in production is there's a gap there. Getting your dev ergonomics set up so that the developer isn't burning their whole day trying to go back and forth between running on the machine and running in the Node container is a big thing. And it's something we spend a lot of time on. So run and tell that.
Yeah, so from my perspective, that's a softball because I believe so strongly in debugging systems in production. So what you're saying is you're exactly spot on. And I think that for us at Joyent, the ability to debug in production is extremely important. I think one of the immaturities, frankly, of Docker was this idea of oh, no, no one should ever log into a container, you just restart it. It's that is happy bullshit talk. You can't debug problems just by restarting them. That's like a Windows mentality, right? When you need to actually, please, just reboot your computer. Reboot the computer. Debug the problem, please. Act like an educated person. Don't do it.
But you try turning it off and on again?
I did. That's what I want you to do. But I think that I believe that it is, we believe, and I think our technology reflects this, that it's a false dichotomy to have to choose between debuggability and a container. And I think that the way we actually implement Docker containers is a little bit different in that you've got your Docker container. Because for us, your container always runs on the metal. So you always have that production tooling that lives wherever that container is. So if you go in and finally, for a long time, Docker didn't even want to allow you to enter a container interactively before kind of acknowledging that like you actually needed to be able to do this for debugging. So now, if you enter a Docker container on Triton, you've got the ability to run dtrace on it. You got all this native tooling that's always there. Because right now, to Jacob's earlier point about kind of what we're trying to kind of figure out our traction with respect to debugging. There are a lot of anti-patterns out there right now, and right now, what people are doing is they are treating their Docker hosts as pets. We're in this cattle, not pets mentality, and our containers are cattle, but they're being run by pets, and that's bullshit. And so people are, just like SSH into the host and run strace. It's like, okay, now I am going to throw something. Because you shouldn't, the reason that's so fundamentally wrong is that as long as our Docker hosts are acting as pets, then your container always has to run in a VM. And when your container has to run in a VM, containers are complexity additive. And we strongly believe that in order for the container revolution to actually achieve its full promise, you've got to run containers directly on the metal and be managing containers directly. So this is a very long answer to your question, but totally agree that and for us, I think that it's a little bit, it can be, this is when people do get upset, when it feels like people talk about microservices kind of gloss over
I think some of the complexity is also in the fact that when we're fully embracing Docker and stuff, often we are in like more microservice architecture. And there's actually not a good story on most microservice orchestration platforms for like, I'm developing like piece B and it's like A, then B, and then it's calling C and D. And you want to work on this middle piece. And I've gone around to like at container summits and be like, hey, given this, you're working on the middle piece. How do you test it? And they're like, in production. Like if the unit test passed, I shove it in production. And
so at Uber, I was talking to Matt Rennie at Uber. So they were talking to him about this. There is a city in Siberia that is a dev city. It's basically depopulated, and they use that only to test in production. So you deploy your services, and then the dev goes and like tries to get an Uber in this city in Siberia. God only knows if any human actually goes there and they actually introduce Uber, there are going to be so many strange effects in the city in Siberia. But no, just your point.
Is this like the Siberian method or the reverse Siberian method?
Yeah, reverse Siberian. No, they totally disagree with the reverse Siberian guys. It's a total feud. But yes.
Okay. What were we talking about?
I was agreeing with you. I was agreeing with you. That was a long way of agreeing with you.
But going back to the problems I've encountered in that same area were actually also due to the fact that I was like running one piece and I actually couldn't run the complete system, or it was too complicated. We're still kind of working on that story. And I think that's kind of meta tooling around Docker itself. So that's developing, like Kubernetes Drink, right? Is one of those things that's trying to address that. And
yep.
Sure.
Well, and we see that as well, right? In some systems, you want to run a portion of the system on your development work machine. You want to be able to test that integration, right? So, custom scripting approaches or tooling around that, better tooling around that to support that mix of process and containers when you're in development is important, I think. Absolutely.
Well, Peter, I thought the work that you were presenting earlier today in terms of better bringing that whole development system, not just one container, but the whole system.
Being able to turn the entire system up in development and work on it and work on those integrations, because it's fine to have 100% coverage on your code, and you should aim for that, right? But there's still a whole bunch of other failure modes that you need to run the integration on to get to the bottom of, right? So absolutely, if we can improve the tooling around that, I think it's a good thing for everybody. Yeah.
I mean, if you're working with all of your services Dockerized, you can, in theory, download them from your company Docker repo and then basically boot them. And there are tools that just wire them together, so it makes it way easier.
I'm glad you said in theory, by the way. I said I'm glad that you said in theory, by the way.
In theory.
That's not
I've seen it in practice a little bit.
Yeah.
I mean,
you can get real close.
Yeah. I mean, I'm glad I kind of exist in the happy fantasy land of prototyping. So this kind of limits to how complex these things get.
Yeah.
But yeah, I mean, yes, I don't know. Good, tell us, please.
In theory, you just Docker pull all the pieces that you need and you start everything up. I know what we do is for each repository that is a microservice, it has a Docker file. And then you kind of have to know your own dependencies. We don't have a way to define those, but you pull and start those, and then you start yours, like to start the one you're working on. The biggest thing that really gives us, honestly, is just being able to version stuff and being able to push updates. So you can work on something in development, and then you push the results, and then that's what's deployed to production.
So there's a few things there which are like general rules of practice that I found are really helpful. Like, don't assume your dependency is started before you get started, for example. Like, it just makes bringing things up less of a nightmare. Database connections are always interesting because often you need to like establish a connection pool. Actually, I don't have a solution for that. Like, just run it somewhere else and like connect. Like, what does everyone use here for like, I have real important data going to disk, like.
Oh, state.
State.
Did you just sully this conversation with state? Come on, we're state. Everything's stateless.
Stateless.
We're stateless, please. Come
I don't
on.
know. I'm
There's
a pure,
no
I'm a
13th
pure
factor.
functional transform of.
Right, exactly. I mean, it's interesting. For us, anyway, when we did a major transition from a monolith to microservices, and obviously with Node, when we became the steward of Node, we actually had this giant Ruby monolith that was doing what Ruby monoliths do. It was like having a pet bear that has actually.
So we go from bears to cats.
That's right. Well, yeah, exactly. And so when we moved that from a monolith to microservices, one of the first things that we dealt with is how do we actually deal with state? And one of the things that we do, and I'd be interested to know what other people do, is we actually have a single service that is responsible for. We have our own key value service, and that is responsible for state. And that is kind of and yes, if that thing has a bad day, everybody has a bad day.
So you have one pet.
We got one. Well, we got one.
This is like the dog that herds the sheep.
This is the dog. Yeah, we had a sheepdog. Exactly. I got no idea what that even means in that metaphor. But we have got. I mean, in this we deploy this with containers. But you've got a canonical repository of state. It's based. It is a key value store that's got backed by Postgres. That got Zookeeper. I mean, the dirty secret is that we've all got Zookeeper running. Zookeeper sadly is keeping humanity afloat, which is just disgusting to me.
Joe, were you going to ask a question?
No.
I think maybe just bringing this back a little bit, tell us about what you're seeing as the differences between, for instance, deploying with Docker Node versus the more traditional methods when you have a virtualized infrastructure, so to speak. Where what are the patterns that you're starting to see emerge with Docker Node in comparison to more traditional manners of deployment?
I mean, how far back is traditional deploy?
Well, I mean, not even traditional, but current methods, really. I mean,
Prior to JavaScript.
I mean, one of the slightly prior to Docker was to kind of cook VMs on, like, say, AWS. You can cook and snapshot these VMs, and you do. I'm like following the Netflix model. Like, you roll them into an auto-scale group, and that was just really slow and really kind of bulky and heavy. It worked really well, but Docker kind of slims this process down quite a bit.
I think that because it is bulky and heavy, because every VM is like taking a 747 to Hong Kong, you want to load that up as much as you can, and having a big fat JVM that is going to launch on that one VM, that makes sense. And when you kind of slim both halves down, and I think.
So if you take the cost of booting a new service as that approaches a lower, like zero, basically, you get a different division of the code between like code bases and processes.
And you can deploy Node in a VM, or you could deploy Java in a container, right? I mean, it's like these things that don't require one another. They just tend to be a good fit. And Node isn't the only one that does this. I mean, I think we're seeing, the rise of Go. I mean, that is also related. And I think the key is that you've got something that is fundamentally asynchrony is the primitive. I mean, that is the.
I think one of the other key points to make is that model that you're referring to, the Netflix model of brooding up VMs, is immutable, right? You're doing immutable deployments. Yeah. You're shifting these immutable units, be them in VMs or be them in containers, out to production, right? So then your rollback model, whatever, is different compared to using tools like Chef or Puppet, where you're actually going in and mutating servers, right? So I think that's a point to make about containers, right?
Yeah, and two sharply different schools of thought on that, right? In terms of whether you should, and I can see both sides of that argument, whether you should whether you should build kind of in production and kind of build from a recipe versus having that image that you actually are deploying back and forth.
Yeah.
I mean, I think we're coming to having smaller images, containers that we deploy back and forth, but.
So could Node and containers completely replace the traditional JEE or .NET stacks? Or is there still going to be some back-end work that you're going to require the support that Java offers?
I believe it could, yeah, absolutely. I mean, a lot of projects that we work on are trying to take existing platforms that may have been around for 10, 12 years that have grown brittle. They're often .NET or Java-based platforms, and what typically is happening is that the guys that are operating those platforms see competition starting to emerge in the market. The competition is using something that allows them to go faster, so they're getting features out of production quicker. So now these guys are looking at how they can retool their platforms using these technologies to give them that competitive advantage, right? As you're saying there, Bryan, right? With regard to, but those projects are not rewrites, okay? Because there's kernels of like working code, battle-tested production code is of huge value, right? So you're not going to rewrite the entire thing. So what we aim to do in those kind of situations is bring forward new features using containers, using Node, right? But the kernel of the platform where the real value is persists.
So chip it off piece by piece, basically.
I mean, making polyglot deploys just a thing. It's like not a big deal.
Yeah.
It's like use the tool that suits you and that you can support.
Yeah, absolutely. Yeah.
So let's use Node in these pieces, which it really excels.
Exactly. Yeah.
I want to make sure we have questions, and I know someone raised their hand in the back. Great.
Is the caller there, Phil?
Since we're talking about containers, I just would like to know what do you think about Google Kubernetes and Vagrant, if you're familiar with.
Think about what in Vagrant?
Vagrant?
And
Was there
Kubernetes.
I just heard Vagrant.
Google
Kubernetes and
Kubernetes.
Yeah, well, and enter the confusion. Kubernetes I think is great. I think it's very interesting. I think it reflects a lot of Google's idea of what a service should look like. I think that Kubernetes is trying to address really a key question that kind of Jacob alluded to, which is how do you actually do service discovery, service management? How do you take these containers, and Matt was alluding this too, with scheduling, how do you think beyond just single containers and beginning to deploy entire services? And Kubernetes has got some answers to that. I think that Kubernetes is still really early. These are all, and of course Vagrant remains, I think, very important because Vagrant allows you to get to the problem that Jacob was mentioning earlier, where you actually got those binaries. You need to build those Linux binaries on your Mac laptop. So I think that they're very important technologies. I think that the thing that's going to be interesting is that these are all open source. So I think we're going to see a lot more mutation.
Yeah, I actually view it as kind of, you're probably going to cringe because I'm going to say this wrong, but we're kind of racing for like the POSIX of the data center. Like, what is the new way that we treat the whole data center?
Why would I
as
cringe
just
about
one
POSIX?
machine?
I got the love for POSIX.
I don't know.
You got to say the Ryan Dahl way, POSIX.
POSIX. I learned something.
POSIX and REPLs. We used to say REPL. What's wrong? Anyway, yeah, sorry, go ahead.
Who's Ryan Dahl?
Who is Ryan Dahl? Who is that guy? I don't know.
Yeah, we're just racing for like what that abstraction should be, so that I'm no longer thinking, even as the developer, like when I run a process, I'm not thinking like, oh, it's got to go on core 1 and you stick 4 of the memory and whatever bus where the hard drive is. It's just like I'm throwing this at some compute that's wired together by some abstractions, and
magic. You want magic.
I want.
You want adults to make magic for you. That's fine. That's fine.
Harry
That's fine.
Potter magic, where like there's a few rules that I kind of understand, but like.
I'll write that down. Harry Potter magic.
Yeah, not crazy magic.
Not
like,
crazy
magic. I can
not bad
target.
magic.
Well-defined magic.
Okay,
yeah.
fine.
I mean, we're looking for that
Right.
basically. Like, you run a process on your computer. That we all think that's a thing, but there's so many layers of indirection. That's okay. We're all cool with that. Like, why not add one more and call the data center a whole computer, right?
Absolutely like that. For me as a user, and I need to make a decision there, how do I make the decision if I should go with Dockers or have weight VMs such as Vagrant? How do you make that choice?
Unfortunately, I'm getting a lot of echo, so it's really hard to hear
How do
what
you
that.
how do you make the choice? You asked a question.
How do you make a choice between these
Yeah,
things?
let's just say I need to adopt this new container technology.
Yeah.
And I have Dockers, I have Vagrant, and whatever else will.
Right.
Like right now, what do I choose?
Yeah, unfortunately, you're an early adopter
criteria.
right now, and I would love to tell you that, this is the choice. I think I think you're going to need to be nimble in the way that so you're going to be prepared to change your thinking over time as these kind of mutations emerge. I think what you don't want to do, I think it's a mistake to look at all this confusion and back up and say, well, I'm not going to do this, because I think it's too important. But you're just going to have to be very pragmatic about it, because as Peter mentioned, the goal here is to move quickly.
Absolutely.
And you can.
Well, our goal, I mean, that it's like, what problem are you trying to solve is good, and you make different trade-offs depending on it.
That's a good point. Yeah, you mean
like if you're in the ops side of things,
your goal is to move slowly.
You want to move slowly and surely, and like not take too many risks, and you want like, I don't know, those domains are kind of separate. Like product can take the risk, but ops should keep on trucking. So some people want to introduce this to simplify ops. That's actually probably a different story. You'll probably be looking a lot more at things like Kubernetes. If you're coming at this from the developer side, maybe you're just using Docker so you can share your build environments, or so you can reproducibly test it, but maybe in the end it doesn't go into production with Docker. Like, I don't know, it kind of depends on what camp you're in and what your main problems you're trying to solve are.
What I think also, the one thing I would say is that the Docker substrate is probably going to exist in all of these things. So for example, in Triton, you can take a Docker container and point it at Triton. We'll deploy it in production on the Metal. You can take a Docker container and point it at Kubernetes. You can take a Docker container and point it at Mesosphere or Mesos. So I think that there are certain common factors that are emerging. Docker is definitely one of them. Docker, the format. I think the Upstack stuff is still TBD, but it's evolving quickly. And I think you're going to want to just jump in with both feet. I don't know. In terms of, like, Matt, what do you guys do in terms of service discovery, things like that?
Exactly what you just said, honestly. Just to simplify what you just said, try something, and if it sucks, do something else. I mean, just try to fail cheaply, right? So,
I mean, you can start simply too. You don't have to necessarily have like auto-balancing containers that can move around hosts. You can just run it on, host A and hard code a port. That still works as good as the way if you were doing it that way before. It's just now you're kind of you're basically having a repeatable build involved instead of like SSHing in and having like a git post commit hook that like runs all your scripts or something like that.
I mean, it's hard to be.
Sorry, go ahead.
It's hard to be cheap when it comes to Kubernetes. So there are a lot of pieces to that. So trying to set up a cluster and do it cheaply is not really a thing.
I mean, it's possible to operate, Docker containers in conjunction with Puppet if you want to, right? Yeah. You get the benefits of immutability, and you're starting to touch the technology. So, rather than just jumping straight in and setting up a Kubernetes cluster, which is a kind of a big overload if you're not used to that, adopt it in the context of technologies that your team already knows and understands, and migrate over time. But I think I'd echo what Bryan says is too important to ignore.
Well, and I think that Kubernetes too, because Peter's raising a very good point here, that Kubernetes is very opinionated, and those opinions may not match the opinions that you have.
We have a question.
Yeah, you bet.
Yeah, can you guys talk about that data center API, the relationship between cloud providers like Google Compute Engine or Azure, AWS, or even Joyent?
Even Joyent. Hey, thank you. That's a kind of compliment, I guess.
There you go.
Even Joyent.
Even Joyent.
Okay, wow, we're just scraping the bottom of the barrel. All right. We got mentioned before GoGrid.
And the things that are built on top of it, like Kubernetes and Mesos and Mesosphere or Smart Data Center. To what degree is it the cloud providers? What's their role there, and what's the role of just the teams that are creating those products?
So from my perspective, this is why I am, and we at Joyent are very excited about the Cloud Native Computing Foundation. I actually view my aspirations, we're very intimately involved with the CNCF. My aspirations for the CNCF are to act as an IETF for next-gen computing. And I think that putting together, you look at the IETF, I mean, you're trying to think of like, when do many companies come together and have a positive result? Like, other than World War II, there are not very many of them, but the IETF, I think, is one of them, because I think what you're asking for is like, are there going to be standards is kind of like a dirty word, but you need some way of having some common denominator, some common abstraction. If we want to get to Jacob's Harry Potter magical dreamland,
please do,
which as fast as possible. Well, I do think that the IETF did birth the modern internet. Had it not been for the IETF, we would be in a much more vendor-dominated internet, and I don't think you would have some of the same accessibility. So I view the role of the CNCF, that's very important to me. A very important role of the CNCF is a hope to go solve that problem. I mean, it's a kind of a cop-out answer, because I'm just saying I see the same problem, but we need to collectively solve that problem, and we need to get providers, we need to be speaking this kind of same abstraction.
All right, I think we got time for maybe one more question.
Actually, hold on. That's really funny you mentioned that, because we at Modulus we're using Amazon, Joyent, DigitalOcean, and we're very much in that boat right now where we don't really have a good solution, so we have our own kind of scheduler thing, and it's all in an effort to stay agnostic. I mean, we have those providers, but also have people come to us that want like Azure or something like that, and we have to be able to do that.
Yeah, and I'm not just talking in my book when I say this, but one thing I am a little worried of AWS being a neo-Microsoft. And Microsoft from the battle days. These millennials don't understand that Microsoft is actually, what Microsoft is, they're so nice. It's like, no, they tried to rob us of our future. But I'm a little worried about AWS being a neo-Microsoft in that, like, I'll just code to their APIs. And it's like, you really want to not do that. Not just for Joyent, not even for Joyent, but if we all just code to proprietary APIs, we lose our opportunity in a Harry Potter future.
Yeah,
absolutely. Okay, we have a question back here.
I have a question related to the Harry Potter future, and that's what do you think is going to happen after Docker? Is it unikernels? Is it immutable servers? Is it some sort of AWS Lambda-like dream world? Kind of what do you think could replace Docker in a few years, or what's Docker's biggest competition going forward?
Is someone paying you to bring up unikernels? Like, as one of,
I was going to say that before,
as
but
an
I thought you'd
engineer
give me
at
a
Joyent
demerit.
paid you to bring up unikernels and just watch my reaction.
Have you heard about runtime.js?
I think that from my perspective, I think that there is a whole world of experimentation out there. Unikernels are one particularly extreme variant of that experimentation. But I do think that in a containerized future, it allows for more options, more ideas. I don't think we necessarily know what's coming next. I think it's going to be a lot of things.
Yeah, actually, I love the idea of like instead of people having to like learn down the stack, kind of empowering them, I guess bringing the stack up. I don't really know what that means, but like, say you could write a kernel in JavaScript, for example. Like, what cool things could you do? It might be horrible, but like you might start to break ground into these new areas. So you might like a lot of good ideas require a lot of iteration, and if you can make that iteration cheap, you might get something really cool. I don't really know what my answer is.
You can have the right tool for the job too. You can in a world where you've got many more smaller things, there are more jobs to do and more perhaps right tools for them. I mean, it's for stranger things.
So Matt, Peter, what's the future? What are your opinions?
I don't think I could top that, to be honest.
And Joe, you guys make this real hard. I was actually going to say unikernels, but he already said it. So.
Were you actually going to say unikernels?
Yeah, I was going to say unikernels.
Come on. I said this is rigged. This is rigged.
Well, I mean.
All right, well, I think we're out of time, but let's thank our
Yeah, thanks, Cantrell.
Yeah, all right, Randy on unikernels.
That's the way to end it.